Hello everyone. So today we are going to be covering section 6.3 in the book. So in the right we have some following notes. We have the multiplication property of radicals. So it says let A and B represent real numbers such that the nth root of A and the nth root of B are both real. Then for the nth root of A times B, we can separate it into the nth root of A times the nth root of B. Also, what I want to talk about is a simplified form of a radical. So it says, consider any radical expression where the radicand is written as a product of prime factors. The expression is in simplified form if all the following conditions are met. So the first condition is the radicand has no factor raised to a power greater than or equal to the index. So before I continue on number 2, so what is the radicand and what's the index? So for example, if we just look at the nth root of A is the radicand. That's fine. A is the radicand and N is called the index. So what does the first one say? So the radicand, so it has no factor raised to a power greater than or equal to the index. So say for A, if it has to have an index. This is the biggest index A can have, n minus 1. Right? If it's A to the n, as we talked before, the nth root of A to the n, this is A. Right? And this would be simplified. This, on the left, would not be considered simplified because n right here is not less than n. Right? So we could simplify it even further into A. The second condition is the radicand does not contain a fraction. So we'll look at examples about that later. And then the third condition is there are no radicals in the denominator of a fraction. If there's a radical in the denominator, we just multiply. We'll talk about how to fix that later on. So now let's look at the examples. So the very first example, it says the expression the cube root of x to the fifth. It fails condition 1 because the index, so I'll write it down here. So for example 1, the index is 3, but the power is 5. Okay, so the power is 5. Since the index is less than the power, this is not simplified. So the second one, the expression the square root of 1/4 fails. It fails condition 2 because it has a fraction. So how would we fix 2? It would be, we would use that property from yesterday. So the square root of 1/4 is the square root of 1 over the square root of 4, and then we would make it 1/2. Right? And then the very last example, the expression 1 over cube root of 8. This fails condition 3 because there's a radical in the denominator. So, and we'll talk about that later. Now let's get started with our topics. So I smushed topic 1 and 2 together because they're mostly the same. So we want to simplify the square root of a whole number. So our directions are to simplify, and for example 1, we are given the square root of 63. Okay. So how do we simplify this? So first of all, we'll have our table. Again, I should probably make one, but let's make one right now. We want to have a little table that has all of our squares. Give me 1 second. Right, so 2 squared, that is 4, this is 9, 16, 25, 49. Alright, so we're supposed to have a table, so these are our perfect squares. Now, we want to do the square root of 63, so what do? I'm going to look at the first number, that is less than 63. So the first number would be 49. Right. So what is my goal here? My goal is to find the first perfect square that goes into 63 evenly. So looking at 49, 63 divided by 49, it does not give us an integer. So then we go on to the next perfect square, which is 36. 36 also doesn't go into 63 perfectly. Then we go to 25. 63 divided by 25, that does not go in perfectly. But then we look at 16. 63 divided by 16, it also doesn't give us an integer. But then we go to 9. So, but 63 divided by 9, that is 7. So this is the very first perfect square that goes into 63 perfectly. So I'm going to rewrite the square root of 63 as 9 times 7. Right. Now we're going to use the multiplication property. So in this case, I'll put in parentheses, what is our n? Since there is no number showing, n is 2. So 9 times 7, this becomes the square root of 9 times the square root of 7. Right? I want to remind you guys that for any even root, we cannot have a negative number under the radical, but lucky for us, 63 is positive, so we don't have to worry about that condition. Right? If it was negative, the square root of negative 63, what would our answer be? It would be undefined, not a real number. Not undefined, sorry, it would just be not a real number. So now let's continue with our example. Now let's solve. So what is the square root of 9? It is 3. Why? Because 3 squared is 9. And then square root of 7, there is no perfect square that goes into 7. So therefore, this. And this is our answer. Now on to example 2. So example 2, we want to simplify 126. So the same process. When I want to simplify this, I want to rewrite it so I have a perfect square under the radical. So what am I going to do? I'm going to go to my chart over here, and I'm going to look for the first number that is less than 126. The first number is 121. So it doesn't go into 126 perfectly, so then we go to 100. So 126 divided by 100 is not an integer. 81 divided by 26 is also not an integer. When we look at 64, it also doesn't go into 126 perfectly. Then we look at 49, no. 36, no. 25, no. Sorry, let me think. I apologize, guys. Probably should have done this example beforehand. So 126, that also doesn't go into 16. So when I'm doing this, if you don't know, we can always check. So if I did like 126 divided by 16, so it can't go, 16 can't go into 1, 16 can't go into 12, so then 126, how many times? So let's see, I'm going to try 6 maybe. This would be 6, 3, 96. Okay, and if I subtract that, I get 30, so therefore I picked a number that's way too small. So then I erase that, and I'm going to try again, and I'm going to rewrite this 6 to make it look better. And then so I'm thinking about 7, 8, or 9, but 7, I would get a 2, but I want a 6, so I know it wouldn't be able to go perfectly there. If I try 8, then I'll get, in my ones place, I'll get an 8, which is not a 6, so I know that won't be perfect either. And then lastly, we try 9, but 6 times 9 is 63, So 3 is also not 6. So this tells me, after trial and error, 16 also does not go into 126 perfectly. Right? So then we go to our next perfect square, which is 9. So we're going to check. So 126 divided by 9. 9 can't go into 1, so then we go bring it over. So 9 goes into 12 one time. Right? So 12 minus 9 is 3. Since 3 is less than 9, we can continue. So we're going to bring the 6 down. This does go. So the very first perfect square that we get is 9. And so 126 divided by 9, that's 14. So I'm going to rewrite the square root of 126, and this becomes 9 times 14. Now we use the multiplication property, and I'm going to separate it. So the square root of 9 times 14 can be rewritten as the square root of 9 times the square root of 14. And the square root of 9 is 3, plus 3 squared is 9. And now with 14, so I didn't do it up here. So since 7 is a prime number, I just automatically did that. But let's say that we don't know. So let me look at 14. Technically, what we're supposed to do is the process all over again. So we're looking at the perfect squares, and we want to find the first number that is less than 14. In this case, it's 9. But 14 divided by 9, that's not an integer. So, and then 14 divided by 4, that's also not an integer. Since it doesn't satisfy, since it can't go into 3 squared or 2 squared, then we know that then the square root of 14 cannot be simplified anymore. And so this is our final answer.